Welcome. Here we are doing a project in analysis and design of a tall building. Here you will learn to do complete modeling, analysis and design of a tall building project. Okay, this is a 23-story building that we'll be designing according to the criteria as shown. Open the ATAP software. Select new model from the file menu and select the usual options as displayed. Cl- Click on OK. In the uniform grid spacing option, set the number of grid lines as 4 in both x and y direction. And set the spacing values to 6 meters each in x and y direction. Then in this simple story data option, set the number of stories to 23. And both the typical and bottom story height to 3 meters. Now you need to define the set of similar stories. So select custom story data and click on added story data. You can see that story 23 is set as a master story and all the stories are set as similar to story 23. So this means all the stories are similar now. And you will create different master stories to divide the stories into smaller sets of similar stories. Story 1 to story 8 are similar, so go to any of those stories and in the master story option select yes. Then set the other stories as similar to the new master story. Please note here story 8 is set as master story, but you can select any other story from 1 to 8 for that. And set the remaining story as similar to the master story. Now for the next set of similar story, that is story 9 to 14. Select story 14 as master story and set stories 9 to 13 as similar to story 14. Again for the third set of similar stories 15 to 19, Select story 19 as a master story and story 15 to 18 as similar to story 19. The remaining stories from 20 to 22 are already similar to story 23 as the fourth set is defined by default. So now you have created 4 different of similar stories. And you can assign properties to only one set using the similar stories option while modeling. Click on OK to exit. Select the grid only option and click on OK. The 3D grid has been created for you to draw elements on it. Go to Define and select Material Properties. Click on Add New Materials. Select Region as India. Material type as concrete. Standard as Indian. And the concrete grade as M40. Click on OK. Then click on OK again. Again click on Add New Material. And this time change the material type to rebar and grade as HYSD 500. Click on OK. And this time then click on OK again. Similarly, add one more rebar material of grade mile 250. The three required material M40, HYSD 500 and mile 250 has been defined. Click on OK to exit the Define Material dialog box. In the next part, you will learn to define the structure elements of the building. Welcome to the second part. You have already defined the material properties of the elements. Now, you will define the frame and slab sections with these materials. In the Define menu, select Frame Sections from the Section Property option. Click on Add New Property and select the Concrete Rectangular option. Enter a name for the column section of 500 mm by 500 mm. Change the material to M40 and depth and width of the section to 500 mm each. For the reinforcement properties, select Modify and Show Rebar. Select the design type to column and change the longitudinal bar material to HYSD 500 and tie bar material to mile 250. Keep the default values for the other properties and click on OK. Click on OK and the column of 500 by 500 mm section has been defined. Now you will need to define two more columns, which are having similar property as this, with only difference being the section dimensions. So instead of adding new property each time, click on the just defined column and select Add Copy of Property. Here, change the section name and change the section dimension to 550 mm in both depth and width. If you select the Modify/Show Rebar option, you will see that the settings of the previously defined column are already there. So you need not define them again. Click on OK, then click on OK again. And the new column section of 550 by 550 mm dimension has been defined. Similarly, select the column one more time and click on Add Copy of Property. To add another column of 600 by 600 mm dimension as shown. Now that the three column sections are defined, you will need to define a fourth property, which is having a combination of all the three defined column sections. Click on Add New Property. Here under the Spatial option, you will find an option Auto Select List. Click on Auto Select Selection List option. Give a property name for the Auto Select list. Then change the design type of concrete. Then select the three defined column sections and click on Add. The three column section have been added to the auto select list. Then click on OK. Now, while drawing the columns, you will not be using the individual sections, but the auto select list property. And the software will automatically select the best section from the list depending on the internal forces. Add the three beam sections similarly. Click on Add New Property, select the Concrete Rectangular section option. Enter the name of the beam section of 500 mm by 300 mm. Enter a name, change the material to M40, and the depth and width of the section to 500 and 3 mm respectively. For the reinforcement properties, select Modify/Show Rebar. Change the design type of beam, select the longitudinal rebar material to HYSD 500 and tie bar material to mild steel 250. Set the clear cover for both top and bottom bars as 25 mm and then click on OK. The rebar properties of the beam section has been changed. Click on OK and the beam section of 500 by 300 mm has been defined. Now, you will add two more beam sections which are having the same properties except the dimensions. So click on the just defined beam section, select Add Copy of Property. Change the property name for the 550 by 350 mm beam section and set the depth and the values of 550 and 350 respectively. Click on OK and the beam of 550 by 350 mm section has been defined. Similarly, select the beam one more time and click on Add Copy of Property to add another beam of 600 by 400 mm dimensions as shown. Now that the three beam sections are defined, you will add the Auto Select List property for the beams, just like you had done previously. Click on Add New Property and select this Auto Select Section List option. Give a property name for the Auto Select list, then change the design type of concrete. Then select the three defined beam sections and click on OK. You now have two properties, one beam auto select and one auto select, column auto select, each of which are having an auto select list of three beams and column sections. As explained, the software will decide the most suitable section for each and every element, depending on internal forces and stresses. And all you need to do is draw the frames using the auto select properties. Click on OK to exit the frame section dialog box. To define the slab section, select Slab section from the Define menu. Select Add New Property. Enter the name for the slab property and change the slab material to M40 and thickness to 150 mm. Click on OK. And the slab has been defined. Click on OK to exit. In the next part, you will learn to draw these defined element sections. Welcome to the third part. In the plan view, go to Story 1 by using the arrow keys. Select Quick Draw option from the Draw menu. Alternatively, you can select the Quick Draw Columns icon from the shortcut bar. Now that you are well versed with the draw icons, most of the draw functions are selected from the shortcuts in the video. After selecting the Quick Draw option property, change the column property to the Column Auto Select List property. Before drawing the elements, select the Similar Stories option from the bottom right corner. Then select the whole grid area to place the column of the grid intersections. As you had selected similar stories, you can see that the column have been drawn in all the stories, which have been defined as similar to the current story, that is story 1. Now select the Quick Draw Beam option from the Draw menu or the shortcut bars. Change the property to the Beam Auto Select. And then select the whole area to draw beam over the grid lines. The beam have been drawn in the set of similar stories from story 1 to 8. Again select the Quick Draw Slab option from you can do from the Draw menu or the shortcut bar. Change the property from the Define property of Slab and select the area to Slab on Sync. The beam column slabs have been drawn in the first set of similar stories. Using the arrow keys, go to any one of the stories from 9 to 14. Make sure Similar Stories is selected and click on Quick Draw Columns. Select that the Auto Select List property for column is displayed, and draw the columns over the desired area as displayed. Similarly, select Quick Draw Beams. Check that the correct property is selected and carefully select the desired area as shown. Make sure that the correct area is selected for each set of similar stories, which has been accordingly illustrated here. After the beams are done, select Quick Draw Slab and draw the slab of the desired property over the area. The beams, columns, and the slabs have been drawn in the second set of similar stories, that is, story 9 to 14. Now go to any of these stories from 15 to 19. Select similar stories Select similar stories and click on the Quick Draw column option. Select the column Auto Select property and select the desired area as illustrated. Again, select Quick Draw Beam, check the correct beam property and select the same area to draw the beams. Select the Quick Draw Slab option and repeat the process of selecting the particular area. Press Escape to exit the draw mode after the slabs are done. Now go to story 20 to draw in the last set of similar stories. Select Quick Draw column and set the Auto Select property for columns. You can draw using the similar story option as before, but here an alternative option has been illustrated. First select the one story option and then draw the columns on the required area as displayed. Similarly, draw the beams and slabs using the respective Quick Draw option. Then press Escape to exit the draw mode. Now, with the one story option selected, select the whole area. So that the beams, columns and slabs of only the story 20 are selected. Then go to the Edit menu and click on Replicate. Select the Story tab in the Replicate box. The elements are already drawn in Story 20, and you need to replicate the same element to the rest of the similar stories 21 to 23. So select Stories 21, 22, 23 together and click on Apply. You need to replicate the same elements to the rest of the similar stories 21 to 23. So select stories 21, 22, 23 together and click on Apply. You can see that the selected elements have been drawn in the remaining stories. This alternate You can see that the selected elements have been drawn in the remaining stories. This alternate technique may be used to draw elements on a particular set of stories without using similar stories option. Click on OK to exit. So the beam columns and slabs have been drawn in all the floors of the building. In the next part, you will learn to apply the dead and live loads to the building slabs and claddings. Welcome to the fourth part. Now you will learn to apply the loads on the slabs and claddings. Since the dead load is same in all the stories, select the all story option. Then select all the shelves one by one in story 1. If there are no shelves in the higher stories of the particular shelf, it will not select anything in that area of the higher story. In this way, by selecting the maximum shelves in any story, that is 9 in story, you are making sure that all the shelves from all the stories are selected. After all the shelves are selected, go to the Assign menu. Choose Shell Loads. Click on Uniform. Set the load pattern name to Dead Load. Enter the uniform load value of 2 kN per meter square. Then click on Apply. The dead load of 2 kN per meter square has been applied on all the slabs of the building. Click on OK to exit. Now you will apply the live loads which are different for different set of stories. So select similar stories and select the slabs again. This time, only the slabs of the story similar to story 1, that is story 1 to 8 are selected. You can verify that 72 shells are selected. 9 shells in each floor multiplied by 8 floor gives 72. Hence your selection is correct. Go to Assign Shell Loads and click on Uniform. Change the load pattern name to Live and change the value of the live load to 5. Click on Apply and click on OK. The live load has been applied on stories 1 to 8. Now go to any of the stories from 9 to 14. Choose similar stories and select the shells. Then go to Assign menu, choose Shell Loads and click on Uniform. Change the live load value to 4.5 and click on OK. The live load of 4.5 kN per meter square has been applied to the slabs of story 9 to 14. Similarly, go to any of these stories from 15 to 19. Choose the shells using the similar story option and assign the live load of 4 kN per meter. Choose the shells using the similar stories option. Verify the count and assign the live load of 4 kN per meter square from the shell loads option of the Assign menu. Go to Assign, then Shell Loads and click on Uniform. In the Uniform Load option, type 4 kN per meter square. Click on Apply. Then OK. Once you are done, go to story in the last set, that is story 20 to 23. Select the shelf and assign the live load of 3.5 kN per meter square in a similar manner. The dead load and live loads have been applied to all the stories of the building. You will now apply the cladding loads as you are going to use auto chalk cladding. Go to story 1 using the arrow keys. Although the cladding load is same, the external beams are different for different sets of stories. So you cannot select the all stories option. Choose the similar stories option and carefully select the exterior beams. All the exterior beam from story 1 to 8 will be selected. Go to Assign menu, choose Frame Loads and click on Distributed. Enter the uniform load value here of 0.2 kN per meter and click on Apply. Click on OK to exit. The cladding loads have been applied to the exterior beam of the story 1 to 8. See, you can see at the borders of the walls, 0.2 kN per meter square is shown. Next, go to the one of the stories from 9 to 14. Here we noticed in left corner, stories option is not displayed, right? So go to display menu and select the undeformed shape. See, it's shown now. Select the similar stories option now. and select the exterior beams. Okay. Now, once the selection is done, assign the unit form load of 0.2 kN per meter square. Click on apply, then click on OK. Similarly, go to the next set of stories, that is 15 to 19. Click on again display and deformed shape. Make sure similar stories are selected. Now again, select all exterior beams carefully. And assign frame loads. Click on distributed. Uniform load 0.2 kN per meter square. Apply and click OK. Now go to the last set, that is 20 to 23 stories. And follow the steps as shown previously. Once you are done, you will need to remove the cladding loads from the beams of the topmost story. As there are no walls above them, go to the last story, that is story 23. See, stories option might not be displayed, so again click on display and undeformed shape. Select the one story option. Then select the external beams of the 23rd story. It should show 6 frames selected as there are only 6 beams in the topmost floor. Go to assign frame loads and select Distributed. Choose the option Delete Existing Loads and click on Apply. The cladding loads have been removed from the topmost story. Click on OK. Now go to the base. Select the base joints using the one story option. And change them to fixed from the restraint options of the Assign menu. Go to the Draw menu. Select Auto Draw Cladding. Select the Use Floor options and click on OK. The cladding have been drawn around each floor of the building. Now you will learn to apply one final set of loads, that is wind loads, to the external cladding. You can notice that the building section is not uniform throughout the height of the building. Thus, the windward-facing shelves will be in more than one elevation. If we consider that the wind is blowing from the left side, then it will directly hit some claddings of the section A and some claddings of section B depending on the story. So you have to carefully select the cladding section wise with respect to each side of the building. You will understand more clearly as we proceed with the steps. First, define the wind load. Go to the Define menu, select the load patterns, type the load name as wind, select the load type as wind, and in the auto lateral load option, select the IS code of wind load, that is IS 875. Then click on Add New Load, and the new load will have been added in the list. Select the newly added wind load and click on Modify Lateral Load. Here for the wind load settings, we have to refer to the IS 875 Part 3. When we open the IS code, consider the building to be built in Bangalore. The corresponding wind speed comes to be 33 meters per second according to IS code. Enter the wind speed value, 33 meters per second. From the terrain category, refer to the clause 5.3.2.1 in IS code. You will notice that the Bangalore falls under the category 3. Select the option 3. Again, for the structure class, the height of the building is more than 50 meters as we notice in the project. So select the structure class as C. As discussed earlier, take the risk coefficient value as 1, corresponding the mean design life of the building as 50 years. For Bangalore, the upward wind slope will be less than 3 degrees. So take the topography factor K3 as 1. Click on OK to store the settings of the wind load. Click on OK to exit the load pattern dialog box. You will now be assigned the wind load on the building cladding. With the Plan View tab selected, click on the Elevation option. Select the elevation side A and click on OK. Select the All Stories option and select all the cladding shells. To identify the wind pressure coefficient, open the IS code again and scroll down to table 4. The height of the building is 23 times 3, which comes to 69 meters. The width and the length of the buildings are both 18 meters. Thus the height by width ratio is 69 by 18, which comes to 3.83. As the value is between 1.5 and 6, go to the particular subcategory of height by width ratio. The length and width are both 18 meters, so length by width ratio is 1. Hence go to the subcategory of length by width ratio between 1 and 32. Check for the wind pressure coefficient under this category. The coefficient are plus 0.8, minus 0.25, minus 0.8 and minus 0.8 for the sites A, B, C, D respectively, per the building's plan on the IS code. Now in the software, the shells are already selected. So go to the Assign, Shell Loads and click on Wind Pressure Coefficient. Change the coefficient value to plus 0.8 and select the Windward option. Then click on Apply. The wind load has been added. Then click on OK. As visible from the 3D model, the side A of the building planned in the IS code also corresponds to some shells of the section B in the higher stories. Select the elevation option and select the section B. Click on OK. The remaining claddings in the windward side of the building which will be subjected to the wind loads are visible. Using all the story options, select all the shells. Apply the same wind pressure coefficient of 0.8 in the windward direction of these shells. Once wind load is applied, go to the plan view option here and select story 1 and click on OK. Now the opposite sides of the windward direction, that is the side B from the IS code, corresponds to seismic section C and D for different stories. First go to the elevation view, select section D and click on OK. Select all the shells. The corresponding wind pressure coefficient for the side is 0.25, minus 0.25. The wind load is applied in the section D. Go to the elevation view option and select the section C. The wind load in this section will also be 0.25. Select the visible shells. Apply the wind pressure coefficient minus 0.25 in a similar manner. The wind loads on sides A and B as per ICE code has been applied. Now you will apply the wind loads on the other two sides which have the same pressure coefficient of minus 0.8. In the elevation option, select the section 1 and click on OK. Select all the section stories. Since the coefficients are same in the other section also, you can select them together. Using the up and down arrows keys, navigate to the elevation section 2, 3 and 4. Once all the shells are selected, go to Assign menu, click on Shell Loads, then Wind Pressure Coefficient. Type minus 0.8, select the leeward or sides and click on Apply. The wind load in the elevation section 1, 2, 3 and 4 have been applied. The software will automatically understand the exterior surface of the shells in each section and thus apply the direction accordingly. You can check the loads from the plan view. Select story 1 and click on OK. The loads are applied in all the shells in each sides. Go to any story from the second set of similarly. For instance, go to story 10 by selecting plan view and choosing the story. You can see the loads are applied to the exterior shells even if they are in an interior grid section. In this way, you can verify the wind loads and direction in the other sets of similar stories as well. All the properties, section, and loads have been applied to the building model. Now you will learn to run analysis and design on it. Select the 3D View tab and select the Use Extruded View for the frame objects option from the toolbar. The frame extruded view of the building. Go to Analyze menu and select the Run Analysis. Save the file if you have not saved it before. As the number of stories is more, the software will take some time to run the analysis on it. Wait for some time for the analysis to complete. You can check the progress of the analysis from the bottom bar. Once the analysis is completed, you can check for the displacement values. The other analysis results like forces and stresses can be viewed by selecting the suitable option from the display menu as shown in the earlier videos. After analysis, you will run design on the building. In the design menu, select concrete frame design and click on Start Design Check. Wait for some time as the software runs design on the building. Just wait. takes time. It takes hardly 1 minute. Yes. Now you will get a notification that analysis and design sections differ for a particular number of frames. This means that initially the software uses the smallest concrete frames from the auto select list, which we did earlier, which is the 500 by 500 section for columns and 500 by 300 by beams. Okay. So in this case, out of all these frame members, 706 members of frames have been failed, and thus the software asks for permission to retreat analysis and design. So click on yes. That is changed to higher section, that is 550 by 550 by columns and 550 by 350 for beams. Now the software will increase the dimension of the failed frame section from the auto select list. You will automatically run analysis and design again. This will reduce the time as we are not able to select each time. This time after the completion of running design, it shows analyze and design section differ for 9 concrete frames. So we have to retreat it again so that the software will again give it a higher sections, that is 600 by 600 for columns and the beams of 600 by 400. Still here, analyze and design section differ for 8 concrete frames, then again click on OK. It will take few more minutes. If the dialog box appears that no section can be failed, so you can check by going to design here and concrete frame design and selecting verify all member passed. A notification will appear that all concrete frame passed the design checks. It take few minutes, then I will show you. I will retreat it later, but I will show you. Wait. When the imagine that when if any notification appears saying that some elements are still failing, you repeat the process of iteration. Okay? You can check by going to design here and concrete frame design and click on verify all member passed. A notification appears that all concrete frame passed the design test. All concrete frame passed the design test. Click this notification appears. Click on OK. The building now has beams and columns of different sections from the auto select list. In this way, you can take care of passing all the members of the building without individually selecting the failed members. Thus, the design of building is complete now. You can zoom in the 3D model and check reinforcement values in each member. Right click on any member to check the design criteria. Here, station location, top steel, go to top stealing, bottom steel, shear steel, all the values are here. You can check there. In my software, there is no detailing option, so I'm skip this tab. So guys, our project is completed. Thanks for watching. I hope you get all my explained points as I learned it from Skyfi Labs, and I will highly recommend you to take online classes for any software you want from here. Thank you.